In this video, we're going to look at graphing step functions. So number 20, the domain of the piecewise function is negative infinity to positive infinity. They want us to graph the function and then use the graph to determine the function's range. So our function is over here on the right. So it's 1 if x is less than or equal to negative 5. So at 5, it's going to be a positive 1, so it's equal to, so I'm going to put a closed circle, because this tells me I definitely have the point 5, 1. All right, when x is 5, y is going to be 1. Now, it says that it's always 1 for anything less than or equal to 5, so that tells me this graph is going to go to the left here along 1, and since my domain was negative infinity, it's going to keep going to that side, so I'm going to put that arrow there. So this one represents that first part of the function. The second one, negative 1, if x is greater than 5. So that tells me, again, at 5, or greater than 5, but we'll say for 5 for now, it's going to be negative 1. So 5, negative 1 would be here, but since it's not equal, we want to put an open circle, and then we want the numbers, the x is greater than 5, so it's going to go this way. And again, my domain is negative infinity to positive infinity, so it's going to go forever to the right. So let's match those up. So that's what my graph would look like. It's going to stay along 1 for anything from 5 and left, and then from 5 and right, it's going to be at negative 1. Now, part B, use the graph to determine the function's range. So my range, right, what is that going to look like? That's my y values. Well, what's going on in this problem? I only have 2 potential y values. No matter what, my range, my y values, are either 1 or negative 1. That's literally all they can be. So my range, I'm going to say, we're just going to make a list. It's not supposed to be negative. It's 1 and 1. Those are the only possibilities for my range. All right, nothing in between counts, nothing above 1, nothing below negative 1. That's it. So this piece here, that is my range. Now, notice I did not use parentheses or brackets. All right, that's not a grouping. I'm listing specific numbers. And that is drastically different than had I written something like this or like this. All right, this is saying the first one here, that's saying negative 1 to 1, so all those numbers in between would be included. That's not the case in this problem. So we do not want to say those numbers in between, so this would be incorrect. All right, so let's move on to number 21. A telephone company offers a monthly cellular phone plan for $25. It includes 250 free minutes plus 25 cents per minute for additional minutes. The following function gives the monthly cost for a subscriber, where x is the number of minutes used. So they've already created the function for us, which is nice of them. So you've got 25 when it's between 0 and 250 minutes, including 0 and 250. And then it's 25 plus 0.25 times x minus 250 for greater than 250. Simplify the expression in the second line. All right, so let's start with that. We're going to take 25 plus 0.25 times x minus 250, and we want to simplify this. So I'm going to distribute that. I get 0.25x. 250 times 0.25, so 1/4 of that. That's going to be 62.5. So I'm going to subtract 62.5. So 25 minus 62.5 is going to be negative 37.5. So I'm going to write this as 0.25x. And if I combine these two, I get minus 37.5. So that's the second line of the piecewise function. That's simplified. And now it says, then use point plotting to graph the function. My minutes and my costs are going to be positive, so I only need to worry about this top right quadrant. What I'm going to do is I'm going to go up by, let's say 50s. I'm perfect, so this is 100, 200, 300, Now these are my minutes. And then my y values will be my costs. So let's say that those are going up by 5. So 5, 10. Actually, let's go by 10, sorry. Be a little bit easier. So let's say 10, 20, 30, 40, 50, and 60. So for the beginning, whenever it's 0 through 250 minutes, we're paying $25. So that's going to be from here. We're putting a closed circle because it's included, and that's going to go to 250. All right, and then that matches up with about 250. I accidentally wrote 3,000 down here. Let's fix that. And then once we get to 250, our graph is going to start going up. Now, when they say use point plotting to graph the function, they want you to come up with actual x and y values. So I would have to pick values to plug in as my x's. Those numbers, whatever you pick as your x's, would have to be somewhere above 250. So you're going to need to pick numbers over here. Those will then get plugged into here to give you exact values. All right, I'm just going to draw a sketch of this. I'm not going to draw the exact values, but it will look something. It's going to go up. All right, I'm not sure exactly what angle. I'm not worried about that right now, but the idea is that it is going to increase. To answer this question, you would need to be a little bit more specific though. So again, pick some x values above 250, plug them into the simplified equation from the second line, and then that'll give you some y values that you could plot. All right, and finally, let's look at number 24. So we're asked to find the domain and range of the following function, and then they list the pieces for us. So we have x plus 2 for x is less than or equal to -3. So we want to look at -3. So an x plus 2 for x is less than or equal to -3. So I'm going to plug in -3 into that equation. So -3 plus 2, and that's going to be y equals. So y would be equal to -1. So I know I have the point -3, -1. So that's going to be right here. I'm going to put a closed circle because it is equal to -3. Now, we need to graph other points from here. If I'm going to pick another point, it has to be less than -3. So I'm going to choose -5. So I'm going to do y equals x plus 2, and this time I'm going to use -5. So that would give me -3. So now I have the point -5, -3. So that's going to be right here. All right, that gives me 2 points now. I'm working to numbers that are less than -3. So I'm going to draw that down to the left there like that. All right, remember you only need 2 points to draw a line. And since it continues to go down -3, I don't really need to worry about when it stops. So let's highlight so we can keep track. So that was that first one. And that's our work here. So put that one in blue. Let's take a look at the second one. So 0 for x is -3 is less than x is less than 4. So what they're saying is that any value from -3 to 4, your x, whatever it is, your y is going to be 0. So at -3, so that tells me I have the point -3, 0, all the way up to 4, 0. They're just less than symbols, so I'm going to put open circles. So -3, 0 will be right here. 4, 0 is going to be here. And now I'm just going to connect those two. The constant ones are always the easiest. It'd be nice if they're always like that, but unfortunately they're not. And then finally our third one. So the 1/2 x for x is greater than or equal to 4. So I want to do the same thing as I did for the first. I'm going to plug in some numbers. And they're telling us for x is greater than or equal to 4. So I'm going to plug in the number 4. Y is equal to 1/2 times 4, so y would be equal to 2. That tells me I have the point 4, 2. It's equal to it, so we are going to put a closed circle. Now I need to pick any point greater than 4 to give myself a second point. I'm going to choose 6. You could use 5, but you get a fraction. So I'm going to say y equals 1/2 times 6, which means y would be 3. So my point would be 6, 3. So 6, 3 is going to be right here. And then again, we're going to draw those lines. All the points greater than 4, so we'll draw an arrow that continues on forever. So now they want to know the domain and range. For us, the domain is our x values. And what's going on here is that the graph continues going left forever. It continues going right forever. And we just need to know if there's any gaps in the middle. So any number I pick along the x value has something matching up with it on the graph. Even at -3, although there's an open circle on the axis, if I drop down to the yellow highlighted one, I have a value for -3. Same thing if I go over to 4. Although there's an open circle on the axis, if I go up, there's still a value for 4. So my x values, everything is included, right? -infinity to +infinity. My range values, remember they're the y values. It looks like my graph goes up forever. It looks like it goes down forever. But what I need to be careful about is there are some gaps. And I'm going to draw these in red here. There's a gap right here. And there's a gap here. All right, there's no y value in this range from here to here. And then again from there. So I need to be careful. I'm going to list each piece. The range for that yellow one would be -infinity. And that would increase to my y value at -1, and that would be a bracket. Now there's a gap till I go to the next one, and that one goes from -1, or sorry, not -1, what am I doing there? I'm talking about y values. This horizontal line, we just have the number 0. All right, that's it. It works to be 0. We have points along there, so that is included. Even though there's open circles, we do have numbers in between. And then the third one, I never highlighted it. This one here, this green one, starts at a y value of 2, closed circle, so we're going to put a bracket there. And then it goes up to infinity, so it continues up forever, and we're going to put a parenthesis. So since I do have these groups and there are some gaps, I want to make the union of these sets. So my range would be from -infinity to -1. 0 will be included, and then 2 to +infinity. Be careful with domains and ranges when there are gaps. It is a bit tricky what you're trying to figure out early on, especially when you're learning this. It's tough to really think about and process what are they asking. All right, what numbers am I supposed to be looking at? Should I be looking at the x values or the y values? Just remember domain would be your x's and range would be your y's.